Hey there, welcome back. We're going to continue with the rules of exponents. In particular, these are going to get a little bit more involved because we're going to have power expressions that are going to be raised to another power. And then how do I simplify power expressions when I need to use more than one rule? Okay, so we'll take a peek at those two. All right, when we're simplifying a power expression, or what we call a power to a power, write that in there, power to a power, okay? So basically we have like this 3 to the 5th, right? And we're raising it to another exponent to the 4th power, okay? So we could, notice I'm saying we could expand it. We could say, well, that's the same as 3 to the 5th times 3 to the 5th times 3 to the 5th times 3 to the 5th. All right, now here we're multiplying like bases. So what we could do is we could add those exponents and we could get 3 to the 20th. But there's a faster way, okay? Basically what you would do is you would take this outer exponent and multiply it by the exponent applied to each base inside the parentheses. So in this case, we would have 3 to the 5 times 4, which is equal to 3 to the 20th. And we get to it a whole lot faster. This is the same answer, different approach. Let's say we had 3 to the 50th raised to the 40th power. We would not want to use this method at all because we would be expanding, writing way too much, okay? So these are your video questions. So go ahead and answer questions 2 and 3. And then come back and I'll show you the worked out solutions. All right, so we're in this one, in number 2, we have x cubed, and then it's raised to the 2nd power. So that means we're going to go 3 times 2, okay? Okay, x to the 3 times 2. And what we get there is just x to the 6th power. That's the simplified version of the quantity x cubed squared, okay? On number 3, we have a negative outer exponent, but we're going to do the exact same thing. No worries. This is going to be y to the 3 times negative 4, which is y to the negative 12. Now notice what we have here. We have a negative exponent, which we're not allowed to keep that. So we're going to move that y to the 12th to the denominator and change the sign of the exponent to positive and put it over 1. Okay? So don't forget to apply all the previous rules. Sometimes you may have to combine like bases. We'll get to a couple of those examples. All right, now this is the power of a product. Okay, so basically what this says is that you have more than one base. So you have more than one base. But you just apply this exponent to the exponent of every single base on the inside. So what we have here is we have a base 3, that's to the 1st, and we have a base x cubed, and then this outer exponent is going to get applied. So it's 3 to the 1 times 3, x to the 3 times 3. So this is 3 raised to the 3rd power, x raised to the 9th power, and that gives us 27x to the 9th, right? Let's call these number 4 instead of 2 and 3. Let's call these number 4 and number 5. These are your next video questions. Go ahead and work these out and come back and check your solutions if you got them wrong. All right, so we're going to start here. We're going to go 2 to the 1 times 5, x to the 2 times 5, y to the 3 times 5, z to the 4 times 5. So this is 2 to the 5th, x to the 10th, y to the 15th, z to the 20th. And 2 to the 5th is 32. When they're a reasonable number, like in the hundreds maybe, you can go ahead and expand them. But if they get to be like larger, like in the thousands or so, I would leave them as power expressions. And here's our final answer, 32, x to the 10th, y to the 15th, z to the 20th. Okay. The crucial factor on problem number 5 here is that this 4 cubed is outside the parentheses, so it does not get this -2. This only goes to what's on the inside of the parentheses. So we keep our 4 cubed, 4 to the 3rd, y to the 3 times -2, z to the -2 times -2. Okay, so we get 64 y to the -6, z to the +4. So remember that whenever we have a negative exponent, we aren't done. We have to move that factor down into the other level. So this is going to be 64 stays on top. Z to the 4th stays on top because it already has a positive exponent over y to the 6th. The next application of this power to a power is called power of a quotient, and it follows the same pattern as the previous one that we did. We have more than one base, and we're just the exponent of every base gets that outer exponent applied to it. So this 3 gets multiplied by the exponent 4, and it gets multiplied to the exponent 5. So we get a 3 to the 4 times 3 over x to the 5 times 3. So we get 3 to the 12th over x to the 15th. And you can leave it like that because 3 to the 12th is a pretty big number. These are your video questions. Go ahead and answer these and come back if you got them wrong and see if you can find your mistake. All right, so I have 2 to the 1 times 2, y to the 7 times 2. Oops, that's an x, sorry. X to the 7 times 2. Then I have y to the -2 times 2. Okay, and that's over 3 to the 1 times 2. X to the 2 times 2. And y to the 7 times 2. Okay? Okay, so that gives me 2 squared, x to the 14th, y to the -4th over 3 squared, x to the 4th, y to the 14th. Now look how you have x's in both the numerator and the denominator, and you have y's in both the numerator and the denominator. So what we want to do is we want to combine those like bases. So I get 2 squared, that's 4. X to the 14 minus 4 is 10. Y to the -4 minus 14, that's -18 over 9. So that gives me 4x to the 10th over 9y to the 18th. Okay? I think we're going to call this 6 and we're going to call this 7 on the video questions, just so you know. All right, and then we have this one. We have x to the -3 over 4 to the -3. Now notice that I have negative exponent here, negative exponent there. We're going to have to change their levels. So this becomes 4 to the positive 3 over x to the positive 3, which is 64 over x cubed. Right? I'm going to skip this one because it's scrunched over. Let's try this one here. I have negative 2 x cubed y squared all raised to the 5th power. So you always want to remove those outer exponents. So I get negative 2 to the 1 times 5, x to the 3 times 5, y to the 2 times 5. Okay, this is a unique base, this is a unique base, this is a unique base. I don't have any like bases to combine. I don't have any negative exponents. So now I just simplify my coefficients. So I get negative 32, x to the 15th, y to the 10th. Now I'm going to try one with a quotient and a negative exponent, and I'm going to apply that exponent to everything on the inside. So I get 2 to the negative 3. We're going to get lots of negative exponents. X to the negative 3, y to the negative 6 over 4 to the negative 3, x to the negative 6. Okay. Now notice that I have a negative I have a base x here in the numerator and a base x here in the denominator. I'm going to combine those. So I have 2 to the negative 3 x. This becomes negative 3 minus negative 6, so that's positive 3. And then y to the negative 6 over 4 to the negative 3. And now I'm going to flip all of my negative exponents. So I'm going to get 4 to the positive 3, x to the positive 3, over 2 to the positive 3, y to the positive 6. And that's going to give me 64x cubed over 8y to the 6th. And now I'm going to simplify my coefficients and reduce my fraction. And I get 8x cubed over y to the 6th. All right. Now, for your video question, I want you to try this one on your own and then come back and see if you got it right. All right, here we go. My 1/2 coefficient just stays out there. 1/2, 1/2. One half. And then I get negative 5 squared, x to the 4th, y to the 6th. I'm multiplying those exponents. And then I get x squared, y squared, z squared. Now I'm going to combine those like bases. Notice that I have an x to the 4th and an x squared. So I have 1/2. I'm just going to make that a times 25 times x to the 6th times y to the 6th times y squared, that's y to the 8th times y to the 8th times z squared. Notice that I don't have any negative exponents. So now I'm just going to simplify my coefficients. It's 25 over 2, x to the 6th, y to the 8th, z squared. Right, this is our daily assignment that we're going to work on. If you'd like to get started, that would be great. Thanks for listening. See you tomorrow.